Hello and welcome to a new session on the Hitchhiker's Guide to the Glamorous World. Today I'm joined here by Sam Ritchie. Hi, Sam. Nice to have you around.
Hey, thanks for having me.
So, why don't we start by you introducing yourself? And yeah, maybe we start by saying like what is Glamorous Toolkit for you?
Sure. Yeah. So thanks, Tudor, for allowing me to be the guinea pig here. Yeah, I'm Sam Ritchie. I've been a software developer for many years. The past year or so, I've slid more and more into a focus on wanting my tools to be more a part of my life. That's not uh, just about work and just about sort of foisting ads on people. I thought, okay, if I'm going to do this for the next 10 or 20 or 30 years, if I'm going to introduce my daughter to this stuff, what is computing? So I've gone down this rabbit hole in the past, I'd say, year or so of um, trying to bootstrap closure into what it turns out that you all have called the moldable environment, moldable development environment. I started focused on kind of learning and some logo inspired Seymour Papert stuff. So that's all great. I've pulled my head up at Conrad Hinson's insistence recently and saw that, of course, this is a decades old idea and that Glamorous Toolkit has been doing this better than anybody for years now. So you, of course, picked up on this and offered to give me a walkthrough. And so for the purposes of this conversation, that's who I am, an excited, interested, sort of already sold uh, foil for what you're about to show me.
Yeah, cool, cool. Well, so yeah, that's some motivation, and definitely same with Pepper's work is definitely a nice thing to have.
Hmm.
And it's actually surprising to see how long so how far away we went from the original idea of what computing was,
Yeah,
only to find out how difficult it is to reinvent the same thing that was there from the very beginning. It's
yeah,
actually
yeah,
quite
yeah,
surprising.
yeah.
So okay, so yes, indeed. So Glamorous Toolkit is a multiple development environment, and when we started with Glamorous Toolkit, we started from this very from this realization of that developers spend most of the time figuring the system out, and most of that time is actually spent on reading. And then we said, well, there was an interesting, you know, there's a like the oldest reference on the subject I know is from 1979, and
Mm.
I remember writing a paper somewhere like 3 decades later, so about 12 years ago.
Mm-hmm.
I was writing a paper and kind of saying the same thing, like developers spend 50% of the time reading code.
Yeah,
And I was like, what changed?
yeah,
So if you had that problem 3 decades ago, we still have that problem at that time. Is it possible that we are asking the problem that, we're asking or framing the question, the question in the wrong way, or
mm-hmm.
we're
Mm-hmm.
framing the problem in the wrong way? And so that's when we started to ask these other questions. So how else could you look at this space? And so because we were actually spending, or I led this other project before, which was called Moose. That's one of the most the longer one of the longest living platforms in software analysis research, is highly
Mm.
published on, and so like we had lots of activity and research there, and we were creating all sorts of tools and beautiful pictures, and we were writing papers. And we said, okay, so let's see what do we do with these tools in real life. So we went and started to do consulting, and so we started with this first system. We did something there. Second system. The goal here was, can we find something that is repeatable?
Mm-hmm.
Can we
Yep.
find something that, like a magic button that we can give developers, and all of a sudden their lives is much better. Um, right? We just said, okay,
Yep.
we can build so many magic buttons because we built them, right? We
Yeah, yeah,
published
yeah.
them, and
That's right.
those magic buttons produce these beautiful pictures. And so then we just said we just don't know which one to start. So we tried, case after case after case, and the only repeatable thing was that in order for us to be anywhere near meaningful for the problems that people had, we had to customize the tool.
Mm-hmm.
Um, there was no magic button, in fact.
Yeah.
So
Yeah. Yeah.
that was the problem. That was the realization. And then we said, okay, so if there is no magic button, how else? So this is the originally the method was called humane assessment.
Mm-hmm.
So it was specifically focused on how do you read code, and then the observation was that, well, developers read code with a very specific intent of figuring out what to do next.
Mm-hmm.
It's not reading. It's most of the time it's not reading like you would read a textbook or um, I don't know, like a
That's right.
novel.
That's right.
You don't read it in the same way, but you read it with a specific intent of basically making a decision. So this is why we said, well, if this is what we spend most of our time on, that could it be that it's much better or much more interesting to look at software engineering as a decision making business and optimize around that. And so of course, like just talking about this didn't seem to be enough. So uh, even if we had some use cases in architecture, dealing with legacy systems, it was not, like people didn't really pay attention. So
Yeah. It's
Glamorous
really
Toolkit kind of
it's
was born.
I was gonna say it does seem hard. It's even down to things that are so obviously practical. I've worked on systems in the past where okay, you can only work with primitive data types, and you people get used to this idea, and then you add the ability to send like collections over the wire, and people go, why would I need that? It's like even the tools we know we need, it's easy to kind of forget and just get used to. We're happy to mold ourselves as tools to humane
Exactly,
environments.
exactly, right. That inhumane idea, but actually that humane, the term humane is ever since I one of the first books I started to read when I started my graduate um, time was the Humane Interface
Mm.
by Jeff Raskin.
Yeah, I
And
think I
so
have it. I have it right
yeah,
around here. Yeah.
that book had such an impact on me that I wanted to name something humane.
Yeah. Yeah. Yeah.
So the first occasion I had, I called it Humane Assessment. But so anyway, like the reason we built Glamorous, or yeah, well, core reason why we built Glamorous Toolkit was, well, first of all, to validate, but the second thing was to have something that is so concrete that people can't wave their hands saying this is just wishful thinking.
That's right.
It's
Yeah.
just a thing. And so, yeah, here we are. So let's have a conversation.
Here we are. Yeah, I think that's that. I guess we should just get started.
Yeah.
I do think you're just to flag your point about it has been decades since a lot of these ideas came out, which isn't that long, hopefully, in the scheme of things, but still feels longer than it should be given all the other stuff that's been produced in the tech world. What does seem to have happened is that we have all these sort of alien level technology things lying around that the capitalist push has produced. We can do machine vision. You can just pick up. You read Alan Kay's old stuff and his frustration that what you really need is an intelligent assistant that will help you walk around through these environments. And we don't really have that yet, but the pieces to do that are much closer than they were back in the 70s and 80s. So, yeah, I have been thinking that it could be that a lot of the stuff will just work. And if you picked it up now with the instruction manual from the 70s, but I think you've all taken it beyond that, because once you start building things, you learn more, and then you're off. So yeah, I'd love to see, and this is also a new mental model for me. I sort of have in my head a picture of what I want out of a development environment, but thinking the small talk way is I think requires some immersion. So
It does. It does. Yeah. So I mean, if you go back and you listen to for example, Alan Kay's talks, um, but the early ones, so from the 80s or so, like really terrible audio, but like really interesting insights. And one of the things that really stuck with me is this idea that it's so easy to you have terms and then you just get used to them, but you just don't know what they mean, like personal computer, personal
yeah,
computing, right? And he said, like, personal computing was always supposed to be personal.
yeah,
That means that it is not decided by some external authority. It's decided
mm-hmm.
by you because it's personal.
Yeah,
Um, and then, like, if you look around and you look at the noise that we have, right? It's just so many. I just saw a tweet recently from Product Hunt, I think it's, I mean, it's very well intended, but there's like apparently a newsletter, which you can, go to find, to stay on top of the best development tools,
Yeah.
news. So the assumption here is that there must be a ton of different development tools.
Yeah, that's funny. Yeah.
And that's because, right, like there's always this thing that come to you instead of you being able to do what you want with the environment. So, but yeah, let's take a look. So, so this is Glamorous Toolkit. Would you have maybe some specific questions to start from, or?
Well, okay, I'll give you a loose framing for the sort of thing that I'm interested in this environment sort of helping me with, and then feel free to take me off in totally different directions. I think your point earlier about you need to build something to anchor what you're talking about is something I've been thinking a lot lately with my own, I'd say, work or the things I'm interested in. So I came at this idea or this field from the perspective of a learner. I'd like to be able to, I spend all this time reading textbooks and learning things, and it just ends up in my head. I can't see what I'm necessarily studying when I'm reading about quantum computing. But I'm building this great machinery in my mind to visualize stuff. At the end of the day, though, I have really the only exporting media I have is writing and the same stuff that was hard to interpret in the first place. So I came into this with the goal of it would be really nice if I could squeeze a textbook through my mind and get it out in some form that can almost perform itself a bit and make it easier for the next person to understand. So the kinds of things I'd like to make are dynamic instantiations of physics models, little things that can perform themselves. That's the sort of thing I'd like to learn how to build. And I've been coming at it from the Lisp side where I'm writing a lot of functions that know how to go animate things. And I have this loose idea that I'll make things that can be animated, and there'll be a box of those. And then I'll sort of tell the system how to animate those, and I'll ship the whole thing, and people will plug them together. But I think that I suspect that's much more well thought out here. So the sort of thing I'm interested in is, okay, our computers know how to simulate external reality, these internal fantastical systems we know how to make, and those things can sort of perform themselves for us, and they have to perform themselves ideally in a way that is much better tuned to the Ferrari we have in our brains that can see whether physics looks off. Like a thing animating and actually doing its dance is much easier to understand than the equations of motion, just looking at them and trying to run it in my head. So I guess a different angle to come at all this would be I've got a complicated software system and I want to bring that into my brain. My first task, I think, is to take things that are pretty intuitively obvious when they're not encoded in software and to make the software do them, but have the sort of representation or the objects there as a thing keeping everything honest almost. So yeah, I'm really concretely, I'm really interested in pluggable visual representations and just how you could take a system that looks really hard to get and make it more beautiful and easy to understand and almost obvious through, allowing it to show itself in different ways. That's all kind of vague though, so please anchor me in.
Absolutely not vague at all. Yeah. So it's interesting. Like if you look at the original, like in the origin of what they were doing at PART, they put a lot of emphasis on simulation and of actually working with kids to get them to understand the world outside, right?
Yeah.
Through simulations that they would have in the computer, right? This is also what what Samuel Papert was working on, and there's lots of work in that direction afterwards.
Yep.
And it's interesting, when you're listening, like the reason why they were working with kids is because like adults are are too they're too much of a lost cause sometimes, because of all the known way of doing things, or imagining some other things, but even there, the the emphasis was always on how the computation looks like to someone that does not understand computation.
Yeah.
So there is a translation that happens between something that is outside, or some model of something that is outside, and something that some human then can reason about, look at it, and then say, oh yeah, now I grasp that thing of which the computation is a model of.
Yeah.
So let's say if you have a simulation of gravitation, then
Yep.
you can understand gravitation because there is a model of gravitation, or some simulation of it in the computation, and then it's still presented to you in a way that you then can make a formed opinion of the original concept. However, like even a long time into the game, so let's say now if you look, developers, there is another phenomenon that is right there in between, which is, and this is still worth discovering, and that's the computation itself.
Mm-hmm.
So there is the program that is modeling the actual world.
Yep.
Right, and it gives you things. If you look at most systems today, they're very interesting because they actually help humans make decisions about lots of data that those humans will never see.
Mm-hmm. Mm-hmm.
And it's a very interesting thing, right? Because like we in software, we possess this beautiful ability of transforming some abstract problems on lots of details into stuff that we can compress, and then humans can then make decisions like instantaneously.
Yeah.
And that's an amazing ability to have, except that there is always a black box there. And if you look at how the black box still is a black box. So when we started, we said, well, it's not enough to look at this computation outside in. You have to be able to look at it inside out. You have to start looking, because the same principles that apply here should apply everywhere throughout the computation. Mm-hmm. And so this is essentially what the idea of moldable development is. It says what we started from. So let's say, so this is a tour. This is a slideshow. You open Glamorous Toolkit, and now I want to convince you of something, right? And there was an interesting thing you have in your talk about the importance of storytelling, the importance of narratives, about computation. And that's exactly what we think the development environment is primarily. It's a platform with which you construct, consume, and ideally publish or share narratives about the inside of software systems. So when we started the work on Glamorous Toolkit, we started from a single object. We didn't start from large things. We didn't start from large outcomes. We said, how do we fundamentally change how we relate to a single individual object? Mm-hmm. So, right? Now, why a single individual object? Because that's the smallest thing we have in a system. And if you want to change large patterns, you start by changing the smallest patterns when the system has fractal-like properties. And that's why we started from here, right? So, and the idea is quite simple, right? So this is a tool that shows you variables and values, so 6 different objects. And so the narrative that the tool gives you is a generic one. It's applicable to all objects in the world, which is exactly what makes it completely uninteresting, right? It's very cheap. Everybody looks exactly in the same way. Like if you open any object today in almost any other development environment, this is exactly what you will see.
That's right.
Right?
That's right.
But if I flip this thing and if I show you these objects right now instead of those, and all of a sudden, boom, you will relate to those objects in completely different ways.
That's right.
Right? So here, this is like a fraction. This is a folder, maybe a picture. This looks like some curve here, some algorithm, and some data structure. Yep. And that's the idea of moldable development, right? And then we said, okay, if this is an important thing, right? If the only thing I changed here is the form of the environment, like the shape of the things that I'm looking at, and that's just changing the shape, it elicits a much better response. Yep. It follows that the shape is essential. It's not enough to just talk about software. We have to talk about the shape of the software as well, and that's an essential part. That's basically what moldable development is. So, if you think about, people talking about, bad code, and I've done research in code quality, for example, and there the idea was to search for a measure of quality that would then basically guide you towards this is good and this is bad kind of thing.
Mm-hmm.
But then it kind of hit me at some point, says, well, if I have the same piece of code and I give it to two people, and one is like 10 times better at that specific code than the other one, then it must be that it can't just be about the code.
Mm-hmm.
Because if it would be about the code, then both would do the same thing. But right, so they would be both as slow. But if one is much better than the other one, then well, maybe it's not just a property of the code. So, and then this was the original thing. But then if you combine it with this idea that okay, there is a way I look at that code, then all of a sudden I say, well, we're looking in the wrong place. It's not just the system; it's the system and the tool.
Yep. And
so the environment itself has to be a focus. So we started in this. So Glamorous Toolkit is built in a Smalltalk system. It's built on top of Faro, which is a Smalltalk system. However, it extends the base language with the environment as a language.
Yep.
So and that's the idea. So then what does it mean to environment as a language? So first of all, if I look at the inspectors over here, I'll have different views, right? The inspector doesn't know anything about the object. It basically asks the object, simple thing. It's just ask the object, give me something, tell me what is interesting about you. And this is not even a new idea, right? Because we had, for example, like a two-string methods in all sorts of languages, right? But because now this is the 21st century, then we can say a two-widget. And because we assume that because it's a moldable environment, so there's no single shape, there's no single dominant decomposition of anything in the software system. It follows that you need to go two widgets. So then all of a sudden the tool can't know anything, can't assume anything. So everything is just, it comes into the tool, reacts to the context. So that's basically it. And we started, most of our time we focused on just inspectors. So let's start with something over here. So if I go to a playground, so a playground is the place where you just write prototype code. So if I can say 1 + 2 here, right, I can do something like this. But if I say 1 divided by 2, then all of a sudden it tells me it's a fraction, so I can see that. And then equally, if I say I want to look at a file reference, which is a folder, then all of a sudden I see something in that one, right? So I can navigate then afterwards. So now if I look in there and I go here, this is now, I'm going into the file system. Also, my inspector, and by the way, the inspector is supposed to be the most basic tool you have in the development environment. But now the most basic tool we have in the development environment just became a file browser, right? And but then we can do some more here. So let's say if I find,
I see.
If I find here a project, and maybe here's a document, and here's a picture, right? And then all of a sudden I see the picture. So here it's interesting.
Yeah, so what you're showing me, just I'll highlight what's standing out for a beginner is you just took a. It is pretty remarkable, right? You took the scratch pad, you summoned you said, okay, here's dot, that's the current directory. But then suddenly we switched, and we're not in the notebook anymore, or the scratch pad, as you say. We're now in a file browser. Presumably that is also amenable to molding. I could have some other way that file.
This is an inspector, right? This is an inspector, right? Yeah. So let's look at this one. This is a folder. This is a picture, right? And the picture, notice how there's a different view over here. So this file reference, right, has I can look at it like this if I want to. This is variables and values.
Yep.
Right, but now if I do this, then okay, I see that. But if I see a path, right, path makes sense for a file reference that points to a file. Would also make sense to a file reference that points to a folder. So that kind of makes sense in both situations. What else? The other thing that makes sense, is the fact that we can take a look at the source code.
Yep.
So the meta view shows me the code, the static code of the class of which the object that I'm inspecting now is.
And that's what any widget would use to go. If you want to make a new widget or show, this is what you'd act on.
Right. Is that correct? Here, let's say exactly. So if we do something like, let's take something simple, like this is a print string. It's normal, just your normal. So if I now alt click here, what just happened here is that now I have I open here on the right an inspector of the method that implements this. And now this one knows how to present itself. So it showed me, this one. So if I say, something like this, then that one doesn't work. Okay, that it works. So then we have print 2 over here, right? So I just changed it here, and now I have it there.
Yep.
And so what's interesting again is that you can, it's because, again, like we are in the simplest possible tool now.
Yeah.
This is the simplest possible experience.
The most familiar to, the most familiar to the.
Right, but the inspector is the most simplest tool. It's just that the inspector takes the form of something that you can then recognize as being some other tool from some, some other, universe, like a tool that you can name. But then if let's take some, a little bit deeper here. So I can see here that I have a file here called index.pillar. And if I look at this, there's a markup over here. So I can look at it like this. This is a markup.
Yep.
But there's another tab over here that knows how to render itself. But only this one is actually not just it's an actual editor. So it's a markup language here. But the markup language knows, like it live adds or removes things from the scene as I work on it.
Mm-hmm.
So I can see here's a picture of it, and this is a file. So we can even execute stuff here. So I can inspect stuff.
Yeah.
And now here I have an inspector inside the document that I just opened while browsing the file system.
Mm-hmm.
So you can do all sorts of, the combination of the kinds of narratives you can and the paths you can take to the system is just exploded. So if you, one interesting thing here is that people are, often decomposing when they come to Glamorous Toolkit and say, well, what are the features? Right? If you start enumerating features, then you have these very, very incredibly, lots of features. But if you look at the problem as, and this is like a daunting thing, so I will never be able to learn all those features. But if you look at it as a language, then all of a sudden it's much more approachable, because it's just a set of operators that just combine many, many times over.
And then, what are the primitives? What are the ways to connect them? And then there's no, you don't talk about how big that set is. You'd never do that in language and say, what are the sentences you can make?
Precisely,
really
right?
Yeah.
So here, right, I just have, for example, an inspector, and this is a flow. So this is an inspector. The inspector has multiple views. This is one operator. Show me connected views. Show me connected objects next to each other. That's a second operator. And then here I can have, here's a code. And if I execute this code, or if I click on this object, they are the same thing. So code and interaction is actually the same thing. That's the third operator. And all of a sudden with this, I can do a lot. We have more of those operators. It's like the library can grow. But already with this, we can start to do a ton of, handle a ton of different use cases.
Mm-hmm.
So, for example, let's take a look at, let's find let me find here I'll say, we'll go into a folder here, so called Suniverse. It's a mobile application. I like to give this demo quite a lot recently, because we played with it not too long ago. So here, for example, I have a package.json, right?
Yep.
And so this package.json is a JSON, so now I can see it here. And this is JSON. Okay, now let's say that's something, like maybe you want to find out, what kind of dependencies do you have that are not from React Native? So this is a React Native application.
Yeah.
Which dependencies from here you have that do not come from React Native?
Mm-hmm.
Okay, makes sense?
Totally.
Okay, so again, if I look at this as text, then it's kind of like difficult to find out exactly which one they are. But this, of course, not text. This is JSON. So if I go here and I say, well, I already have a JSON parser.
Yep.
And then so if I now tell this one to self here, I just opened here an an object playground.
Yeah.
So self here means this file reference.
Yep.
And if I say self contents, for example, and let me execute
Yep.
that one, I'll get a string over here.
Yep.
Right. So
Yep.
if I now gonna take this string and pass it to the parser, and now I have a dictionary because
Yep.
like with these things. So now here I can see, okay, I have dependencies over there, which means that if I go here and I say dependencies, I'm gonna have those.
Mm-hmm.
Right. And now, of course, these ones are just, now I'm transforming into an array. And so now I can do a select, each for which the key begins with, I don't know, React Native. So now, right, I just have those that come from React, but if I reject those, then I have this.
Here's where my brain goes. Just to like, could you now take what you just wrote and install that as a new widget for this file type?
Absolutely. So let's say, in fact, we already have it. So if I want to just parse this thing, right? There's a button here which says parse it, and I will get this dictionary. Right? This add dependencies, but we can just do one here, that if I have a package.json specifically, then it will have me a dependencies browser for it, right? Mm-hmm. So just for the sake of it, I will now just open here a meta tab. Mm-hmm. So in the meta tab, I will be creating a new method, and I'll say, dependencies or package dependencies. And so this is now a method that will require, it's like a, print on type of method that takes a stream so that you can print your view on it, but it's a stream of visual widgets.
Yep.
So, and I will be annotating that one because now I have multiple of these views in an object, right? So any object defines the views, just like you have a print string type of method.
Yep. Yes.
And so we will package it together with the object, or, well, you can package it separately, but it will be defined in the class of the object, somewhere in the superclass. And so, but in order to discover which of these methods of the objects are actually interesting, our views, we annotate them. So this is an annotation over here.
Yeah, got it.
Okay, so now we say, I want a view, and now we're gonna say, we just want the list here. So let's say I want a list, and the title is gonna be dependencies. Mm-hmm. And when I will be, so what are the items in that list? And the items in that list is going to be, I'm just going to take exactly what I have here at the bottom.
Yep.
And I'll just paste it here, just to, right? So I can say here on
nice.
React Native.
Yeah, that's right.
Dependencies.
And then presumably you could start molding this to say, okay, well, let's have the user supply the prefix, and this can now be an interactive window or an interactive widget.
Right.
Yeah.
So
we don't have to go that road, but yeah, look at that. Beautiful.
Right. And so now it means that if I go somewhere here, of course, I didn't put a condition. Of course, like there's an exception if I look at those.
Yeah, you mentioned that. Yep.
Right. So now I still have to add here a condition. So self, if it's package.json, or if it's not. If it's not package.json, then I'll just return an empty view. And so now I have that one, and if I move to something else, and there is no more.
Awesome.
Right, so even if this JSON, this one appears, I can see it there. And then of course you can do all sorts of things with it, but that's it. So two things that happen here. First of all, the method here is actually reasonably small.
Yep.
So there's like not a lot of code to put there. This is first. Second of all, we constructed the tool pretty much seamlessly, like very little friction. I had a problem, which is a base problem. And then at some point I said, I don't really have a good tool. So I'll now have to do a meta. I have to go a little bit meta, but going meta is so expensive. It's so expensive. It's not, people start to use moldable nowadays as a term, which seems to become a marketing term.
Yeah,
Um,
that's right. That
but
means you're doing
moldable,
well. It's like you're entering big data, big data, deep
something
learning
like that.
territory. That's right.
Right, exactly that one. But moldable doesn't mean pluggable. Like, just if you have a
Yeah,
plugin architecture, that's not what moldable means.
yeah,
Right? It means that you, like, while you work with it, you're just, oh, I don't like the way it works, so let's reshape it more.
mm-hmm,
It's a language that allows you to grow the system from inside, from within.
mm-hmm, mm-hmm.
Um, that's basically what we mean by that. So, but and if you look at how the conceptual framework is, so if I take a look at this one. So first of all, that's basically the space we're looking at. But basically, with moldable development, we are addressing the single largest expense that nobody talks about today, right? So
Mm-hmm.
developers do spend all of this amount of time, figuring the system out. But if you ask them, when was the last time, they talked about how they read code? So not about the code that they read, but about how they do the reading.
Yeah, yeah.
That's rarely a subject of conversation, right? So it should be. But so,
It's not just
what I
that; it's
should,
that many people who say that code reading is the most important thing, it's for one reason or another, don't do it that much, or when they do it, or when they write, they're not actually writing to that purpose. Like, code is a lot of things, and that extra step of writing and narrative, I think when it's an afterthought, it just doesn't really happen often, or when it does, it happens in a way that's not, you can't go back to the original thing. You get this nice polished presentation that is not actually the original thing anymore. So yeah, I'm with you. It's people are doing different things behind closed doors that they say they want to do, and yeah, it's a black box for all those reasons.
right. But the point here, we also, but then you can take it a step further. We're saying, but actually, what we're challenging is the reading. It's not the time people spend, but the reading as an activity, right? Because from a decision making perspective, um, the reading is just the means by which you extract information out of data.
Mm-hmm.
It just so happens to be the most manual possible
Yeah, yeah.
means, and it's also the primary reason why we in software earn so much money,
Mm-hmm.
because, like, we automate everybody else's work.
Yes.
We should employ those magic skills for our own little problems.
It's
And
fair.
the
Yeah,
way
yeah.
conceptually works, right? You start always from a question and say, oh, how was those dependents? How, what dependencies do I have? And then I'm asking myself, so what kind of analysis would I need? Right? And then if I have the analysis and I get the results, and if I'm confident, then I'll do something with the outcome. But the killer question here to ask is, do I have an analysis?
Mm-hmm.
And if I don't have an analysis, I should go and build it.
Mm-hmm.
So that's what moldable development is. But you notice how this one is like a meta. It's a
Yeah,
meta
yeah,
step,
that's right.
right? I go,
That's right.
and this is so expensive. This is very expensive. Going meta is really expensive.
Yeah, you do it in
So
your brain usually, and then you are left with this kind of secret thing that decays over time and is very hard to communicate, and
right,
doesn't necessarily do the job because it's, how can you check by showing it to someone else?
right. But if you go back to for example, the Humane Interface book, one of the things that stuck with me was this idea of locus of attention, that our brains are mostly adapt to dealing with one single perspective at the same time.
Mm.
So that's why you want to automate the how, so that you can focus on the what, or what you're doing.
Mm-hmm.
And or even if there's something that is new, you want it to be very, very close, extremely explainable, so that there's like the time it takes you to understand the how. It should be very, very small. And that's the same thing that happens here, because what the proposition here says, well, all of a sudden you're going to say, okay, how am I going to do it? And now you have to go and do the how, right? And if this one takes you like a day, then the proposition has lost.
That's right.
Because it needs to be ridiculously cheap for this to actually work in practice. Because we want to apply this one to every single development problem we have. We don't just want to apply them to some of the problems or to the large problems.
That's right.
We want to apply it for the smallest thing. So let's see, what does it mean to apply it to the smallest thing? So here I have this method called, so I have a method here in this case, which is an extension of file reference.
Yep.
And there is this, it's annotated with GTV. So let's see, how many of those do I now have in the, this is a default distribution of Glamorous Toolkit. Okay, so I'll be opening another playground here. And now there's another question that I have. So now it's, how would I decompose this problem? Well, that's going to be a query, right? It's going to be a query over my own code. So we already have a little language with which we can query our own code. So if I can say here, we call these things pragmas, these annotations.
Yeah.
So we say this is a symbol, kind of like a string.
Yep.
And I'm going to say I want the pragma. So this pragmas is actually a little method implemented in symbol.
Yep.
That returns me a filter object. So let's see what happens if I execute that. It's a filter object. Now the filter object knows how to present itself. How does it present itself? What with the list of methods over here? And then of course, if I look at some of those, right? And now it's an editor. And this is now a code editor. Now what just happened here? And this is an interesting thing. What's the name of this tool? Because it's very hard to name the tool.
That's right.
Because, right, like before we could recognize some tools. Here I just open a place where I'm playing with just code, and I transform that one into a query box. Then I get an inspector that gives me an editor, and now I'm going to have, I'm able to now write code in an inspector.
So here's a question. I'm just sort of piling up questions that we can go down as many holes as we want. So this is an area, like, it seems that every part of the system is available to mold or to break. How does the system, or does the system add any sort of graceful friction? Like if I go change the definition of false to be true and everything freezes up, I mean, that's fine, but let's see how to say this. You might want the system to be opinionated about, okay, this should be a little harder. You can do it, but here's how to gracefully back out. There's this sort of, frightening ability that you're showing me to just change anything. Now I'm sure there's some other way you could look at the system where you're seeing the breadcrumbs you're leaving and you can walk backward. So what's the story there on this sort of stuff? I mean, I'd be nervous to change things as I get deeper and deeper.
So the thing is that this system is a throwaway, right? This is an image, just like people would consider Docker images being a throwaway, right? So it's not that much of a difference. And so, I broke that specific Docker image. I played inside that Docker and I throw it away. What do you do? It's going to say, oh, no. No, you're not going to say that. You're going to say, I don't care. Right. Yep. Why? And then you're going to put processes in place. So how do you deal with that situation? Well, you're going to deal with this by saying, I'm going to make a small change. I'm going to see, I like this one. I'm going to commit it back.
Yeah.
Because this whole image over here is actually produced out of source code. It just came from GitHub in our case. And it's just, there's a pipeline that produces it, and I have a new image afterwards. So I don't have to have those in place. Now, would it be interesting to have immutable code? Absolutely, super interesting, right? So then there are some interesting projects out there, right? Yeah. But there's a pragmatic side of looking at things, and then there is the ultimate goal. But yes, I would love to have.
Fair. Okay. So here's what was different in my mind. I'm breaking the. What you're saying is, if you had a source tree, if I get the Linux source tree for the OS I'm running and I mess with it and add junk, it doesn't matter. The things I was conflating are, the source code is in this, an image is the source code, but the source code performing itself live. So, if the
image is bootstrapped.
Yes.
The image is bootstrapped out of just plain dumb text.
Yeah. If you change true to false in the source code and your brain says, well, that wouldn't work, you don't make any sweat. You just back out. Right. Here, the system is showing you the consequences live of your changes if you choose to commit them, but there's no pressure to, and you're not actually doing that by changing something in the text.
Yeah. So the point here, so the image is basically, you have, let's say in this case, very concretely, there's something in the repository, and then it's something in the image. Now I'm playing only in the image, and at some point I'm going to say, I already have all the tools here. to simply say, oh, now I like this change. I want to go and commit it now.
Mm-hmm.
And but from the image, which means that I will never be interacting, or I will never choose to interact with my source code without having the feedback of my live environment.
Yeah.
But it should also be said that, in fact, this will become even more apparent when we go into, so right now I'm just showing you how the environment talks with the objects from the environment. But Glamorous Toolkit is actually made for working with all sorts of other technologies and languages.
Yes.
In fact, the second language that we support is the language with which we define the support for other languages. So in terms of, like, for example, parsing and we already have support for even running JavaScript and Python, and other people can start adding their own preferred, connections like Clojure or can be one of those.
Yeah, of course.
And then it becomes even more obvious because you don't have to, right? There is a clear boundary there, or the other. So we see this thing like a lot of the things that are happening here are local, but in fact the future of computation is distributed. It's not, and it's definitely not going to be happening in this image. This is a client-side technology to compose things. Right. So to compose, but I compose the client-side experience of it. I don't compose the runtime necessarily out of it.
Yes. Yeah. And that's why the IDE analogy is useful, but does not tell the whole story. Yes.
It doesn't.
It's more operating system as IDE. There's the you want to attach labels to what this is, but that's very illuminating.
So when I was showing you this one, right, I said, okay, here's a query over the system, right? And it gives me the methods that are annotated with GTView. And this is a live editor over here. But there's an interesting tab here with metrics. And this metrics here says, well, there are 1,197 such views, such methods in the image, in the distribution of Glamorous Toolkit.
Yep.
So there are 1,190, well, we just added one. So there are 1,196 plugins just for the inspector out of the default image. And it's interesting to compare it with other, we were just having conversations there, like, in Visual Studio Code, they have like 20,000 plugins in total. We have 1,000 of them in the distribution just for this one. But the same thing applies to all sorts of other things, like, for example, search. So if I go here, let's say, and I search, and I'm going to say, okay, I want to search object, or you were talking about false. So let's talk false. And now I'm just searching for classes.
Yeah.
Right? So what's interesting here, I can now dive into that class, and now I'm in the context of the class. And now when I say, well, if false and if true, this one now no longer searches for classes, because in the side of a class, other kinds of searches make sense.
Yep.
So the object not only knows, for example, how to print itself, it also knows how to search itself.
Yes.
So that's another way of molding the system, right? And I can go there if I want, and I'm going to jump into the code, right? And now I go into something we call coder. So let's see about this one. So if I'm going to go now into, something called baseline of Glamorous Toolkit.
Mm-hmm.
Now this is like an NPM definition, but we define it as a class, not as a package, not as a package JSON or so, right? And so you're seeing here all these other projects that this is made of.
Yeah.
Now here's an interesting thing. So I can see here, okay, this is a baseline, and then there is a string over here.
Yep.
And now this string has a triangle, right? So it's interesting. If I delete this thing, the triangle disappears as I type, and I press D, right? The triangle appears. In fact, I even have completion inside the string, and I can find it. And if I now expand that one, this is going to be another class, which is called baseline of gtoolkit clipboard, which is actually handled by this other little internal DSL. Notice how there's a super class called baseline of, there's a special method over here, there's a special call. And because I know all that, I can introduce this little tiny operator that when I expand, is going to show me exactly just that method that will be resolved by the framework at runtime, right? Because it's not the same name, right? This is a string and it's definitely not baseline. So if I look at the code only,
That's right. Got it.
I'm not going to see it, right? And so the code itself is also moldable.
Yes.
Like the coder, the editor is moldable. In fact, every tool we create is moldable as I'm running it, just so that we can create all sorts of interesting experiences.
Yes.
Okay. So, for example, and I'm just going to give you another one. So let's say talking about how do you construct views, right? Because now that's another problem. Yep. So everything we have, right? So people sometimes ask, so how do you learn Glamorous Toolkit? So the way you learn Glamorous Toolkit is that you learn how to learn Glamorous Toolkit, because Glamorous Toolkit already comes with the tools that explain itself, that you can use so that you can learn to build mental models that are more appropriate about the inside of it. So for example, for learning about inspected views, we can have something like this. So it says, well, first of all, maybe go and learn Faro over here. Let's come back to that a bit later. So here it says, I have this kind of thing. Here's how I create the list. This is what I did before. And I'll notice how, like, if I do this, I just constructed a seam here that kind of tells me how these kinds of things connect. Like I don't have my mental muscle can focus just on the concept.
This is beautiful. Yeah.
And this one is actually live. So if I remove this T, then this line doesn't work. And if I add the T, then the line works.
Yep.
So, and now that's because we added here a little operator in this one, which is just a little bit of, a little syntax highlighter that is active and introduces these beautiful little tiny things that are anchors, and then I can use to then connect them with other things in the scene. So there are all sorts of these kind of libraries, and once you have a number of them, then the combinations are very large.
Yes.
And then you add just one more, and then you see everything explodes. And so that's what we think that the future of computation is.
Hey, so let me inject one question, which just so so here's one question. So you made the analogy earlier. You said VS Code has this many plugins, and then each method you could think of as a plugin just on one of the objects. So how would I think if I were working in Glamorous Toolkit about, I don't know, multiplayer or publishing these things or sharing? Because I say I focus on a system, I'm going to learn a lot and be building these representations for it. When I share those, what does that look like? Do I move back into the sort of stale black and white GitHub world where people I'm sending pull requests to other people's repositories, or is there sort of a similarly beautiful story for, hey, just browse my thing, take this, or do and just to frame, I see I know you got the answer here, but to frame, I've been struggling lately with a small team I'm working with where we all have, say in this Rome research context, we're all writing kind of text and we're processing books into ideas. But when it comes to sharing sort of the mental graph of my reading notes with someone else, like that's really hard. It's really, we don't use the same words for the same terms. So there's this very jarring boundary when you go to share. Like let me try one other way of saying this. I can imagine that molding a tool makes the tool extremely personal. And there does seem to be a little tension there between me creating personal things and then me sharing them. And a system might suggest hygienic ways or sort of there might be some social contract around what to share and how to share it. And I'm really interested about that.
Well, so the way things happening at the Glamorous Toolkit level is that this is targeted for developers. So developers already know how to share things. So this Git world is terrible, but let's say it's pragmatic enough.
Okay.
Just because, we are already turning quite a bit of the world upside down. So turning everything upside down all of a sudden, that's not a practical thing. No,
this is not a criticism. I'm genuinely
I'm just saying. So from this perspective we just say at this point in time, we rely on Git as a means of sharing computation between developers.
Great.
Does this mean that there is no other way to start sharing things to non-developers? Absolutely not. We think that
Yep.
there are lots of opportunities or interesting things to work on at that level.
Yeah. One goal I'd had with or one I guess wish I'd had for myself is okay. You go and you make a thing. You make some physical simulation or a system that you want to share, and with the normal tooling that I have available, to share that with someone who's not a developer, they have to get this whole tool chain running, and it's the web seems like a nice way to spread stuff, and you can do it with things that are primarily to consume, but it's hard for people then who want to get involved to grab the thing and start playing with it. And JavaScript starts to provide some. Everybody does have an execution environment in the browser. It's clearly not what we have here. But yeah, this is the the problem with giving people these tools is that you immediately go, oh my God, I think the better world is here. How can I just add a method and then my friend can immediately see it and we can start sort of playing across machines? It's very beautiful that this tool suggests next things to make that expand its worldview's impact.
Sure. And as I said, I think there's a lot of opportunities that go around
Yep.
there. But
Yep.
the first thing that we worked on or that we wanted to get right um, was this idea: how can we approach a learning problem about various facets of a software system
Mm-hmm.
without in a systematic way? That is, you learn a technique once and then you apply it over and over again with the same set of tools if you want. Um, and then you can still augment your abilities, let's say maybe 10 times better than the current baseline, which is like
Yeah.
the
Yeah.
lowest possible
That's right. That's
baseline.
the table stakes.
So
That's right.
so that's the first problem that we have solved. Now, in the process of that, we did find that we can solve, or these principles lend themselves to all sorts of other domains,
That's
um,
right.
that are definitely worth exploring. So one of the things, for example, here, right? If I go back to the baseline of G toolkit.
Yep.
So an issue that we have is we want to document. So we want to create documentation about Glamorous Toolkit itself. Like there needs to be some documentation somewhere. So if I now look
Mm-hmm.
at the comment of this class, there is a live document, of course, here.
Oh,
So
so good.
and this live document now, I can click on those and I'll get to another one. And so now this one explains to me the inspector. And then of course I can maybe go to another one over here and this will explain to me some other things.
Mm-hmm.
So now I have I just transformed my system into less of a technical thing and more of a tool that a
Yeah.
non-technical person can play with. And yeah, we do think that there's a lot of potential in this space.
I've been writing these Clojure. So I've been doing a lot of translation of scientific computing stuff into Clojure. So ripping through, not ripping through, but going and looking at old Fortran code to do numerical quadrature and integration and things like this. And I just bit the bullet and started writing these things as sort of not really literate programming documents because I'm not using a proper literate environment, but I've got these big sort of I'm rendering the markdown in my head, and they're really source files with just crazy amounts of comments. And the idea is, I know it's not the best way, but I'm just leaving it there for a better tool to come along later. And I'm putting these little inline examples and copying the output in, and it's all pretty janky. But I have this thought of what I want, and it's pretty clear how it would work now inside of Glamorous Toolkit. I would just have source kind of in line, and the literate programming stuff I mentioned in that talk is all obvious here. But beyond that, like this was kind of my goal. What I'm seeing here is I've got source code, but it's interacting. It's interspersed with playful examples, and you can read the source code and feel free just to get distracted and move on and play as a way of learning. And
Yeah,
ideally, the source code in a literate document should be like ejecting you from the literate document as fast as possible and getting you playing. And
exactly.
it's a big triumph. It's like it's clear how to do that here just from looking at the couple of examples you showed me.
Yeah, exactly. So let's see if we can find something. Okay, this one maybe. Oh, this one is not.
Oh boy.
So
This is my
we
new.
can have. So let me share with you
I was going to
another.
say I can see myself spending a lot of time getting Clojure working. So I think you may have successfully hooked me.
Excellent. So here is a documentation of an actual system. This is a really running system. It's a business system. It's about restaurant automation.
Yep.
So here, right, we can say, here's how a workflow works here. And this is now another document. And and here I can see how it worked. But then it's not only that I can see how it worked, I can actually interact with it. I can see stuff that happens there. And this is actually happening. This is the way I embedded this one is through a markup. And notice how the markup only appears when the cursor comes close to it. It doesn't appear all the time. We actually created a whole new graphical stack exactly so that we can start to do things like this, or things like this, where you can start looking inside things in the text. But like, how does this one look like? So we have also introduced another idea, which is that idea of example. So here's something about prices, right? So here I construct the price of 100 euros, and I assert that the price equals 100 euros. And equality here is actually a message implemented in price. So this is not a construct of the language. It's just a message of this is what this one tests. So up to here, you can think of it as, okay, this is like a unit test, right? I set up an object, I assert something, and it's like a unit test. Okay. Now think of the unit tests of today, of unit test frameworks, right? You say, well, a unit test is actually interesting when it's red. As soon as the test is green, poof, no longer interesting, right? It's just
that's right.
Right. But we said, well, what is a unit test, right? It's I go to the trouble of figuring out how to construct a beautiful object. I ensure that this beautiful object has beautiful properties. And then the best thing that the framework thinks of it is to throw it away. And then we say, well, that's like a big waste. So we added this little tiny thing here, which means I'm going to return an object. So my example, my test, returns an object. Now, if I combine this return of an object with a view, then I can start to, I have the beginning of a documentation. So let's see if something that is maybe more, so here's an addition, right? I have 100 euros plus 20 euros, and I want to assert that it's 120 euros. And now, of course, this is actually another object that I constructed there, which is a summed object, which is 120 euros, which is made out of 100 euros over here plus 20 euros over there. Or let's go now to another simulation, which is, price is discounted in various ways. So I have here 100 euros, and I discount it by money, minus 10 euros, so I get 90 euros. And then I discount it by percentage, 10%, and I get 81 euros. So I just described here is now, it's not how these things looks like at the outside. I tell you how they look like on the inside. Right? And this one, so basically, just by changing how we are expressing examples, we have now bridged the gap between, so the effort of testing just became the effort of documentation. Because the only difference between those is I'm just going to construct a narrative, right? So you mentioned an interesting point, which was literate programming. So people look at Glamorous Toolkit and say, well, this looks like literate programming. But there's a very important distinction there. Literate programming had or featured exactly a narrative, a single narrative. It was the narrative of how the person maybe have constructed the system or so, but it was always a single narrative. There is no single decomposition of anything in software system. So you must have multiple narratives. And that's where the difference basically
totally sold on this. I mean, it's true in non-software too, but those are, languages is a good way of bootstrapping the non-narrative thing in your brain. The other thing with what you're showing me here is I've become enamored over the past 5 or 6 years with rather than test-driven development, algebra-driven design, I guess is one phrase for it, where you're writing laws. This sort of, are you familiar with quick check or this?
Property-based testing, for
Exactly.
example.
Yeah, property-based
Sure.
testing.
Sure.
Yeah, and these two extremes, right? Of unit test, okay, property-based testing, the properties themselves are, arguably the core thing you should be thinking about before you write any code. But then between that is this middle ground where what a property does is give you something like an ironclad law that should hold, and the system goes and throws every example it can think of it and tries to break it. But when a human looks at a property, what they really want are concrete examples that we can use to build intuition about the system. And I have had the sense of, as you're saying, we write these laws, they're important, but then we write narrative around examples of them. And at minimum, you want a system that will at least run the example in the documentation for you. And I found a few systems like that, and it's great. But it's like, man, I wish. Why can't you just do the Brett Victor thing and take the slider and at least show me a few other examples of things that I care about? But yeah, what you're showing here is the thing you publish is the system and is a thing you can play with to learn the system and is a thing someone can go rip off and modify if they want. I think a lot of the good ideas about code as communication, need this to work.
Right. Yeah. So exactly, like absolutely, property-based testing is the way to go when you want to ensure laws about your the safety or like the interesting functional properties about your system. By the way, those properties and the kinds of properties you get there, those are also interesting to explain. We can go into that some other time. But yeah, like when you want to teach somebody of something. So like if you think about what people talk when people talk about domain-driven design, which is a very interesting and it's a systematic way of decomposing spaces and getting people to start talking about one another, talking about this ubiquitous language, right?
Yep.
Most conversations around the whiteboard are going to happen around some sort of examples, because that's just, we work like that. We start from the example and we generalize from there many times, right? So it's this empiricist perspective of discovery. But but there's one thing there is that when people draw something interesting on the whiteboard, that whiteboard should be used exclusively when the system doesn't yet exist. Once you have that thing, it's the job of the system to carry it forward. Right. Once you say this is an important presentation, it's the job of the system to then say, here it is. Right. It's that thing that you said it's important.
Yes.
Here is afterwards.
That's right. That's right.
So what we're seeing here is because like everybody was saying, like we had so many. Yeah, because we keep on talking about moldable development as if it's one thing, but you still start peeling off all sorts of things that we start to see how, we just had a single goal, and then to this desk, we had to kind of reinvent a significant amount of space there. So there is the key, one problem people were saying, what we're having with documentation, that documentation goes out of sync with the code, right? So it's difficult to maintain those. And we were thinking, why is it difficult to maintain? So, well, because you have code in documentation, you have code somewhere else.
Yeah.
Why do you have code in the documentation?
Yeah.
Right? Because here we don't have code in the documentation. This is actually a living thing. This is a living editor over here. I can change things over here.
Yeah, we shouldn't have code in the documentation. It should be that, these are things that you happen to pair up for a narrative, but they both are fine on their own. Yeah, and if you want them to be in sync, just as you're doing here, have the documentation built to be an actual, program that runs.
Exactly. So the documentation here, right? If we look at this documentation, actually it's very small. Like the piece of text and the amount of time it took us to write this down, it was measured in a few, 10 minutes or so. But you actually have a documentation that you can give to a newcomer, onboarding, talking with business, building this ubiquitous language. You don't have to trust that the ubiquitous language exists only on the whiteboard.
That's right.
You know that it exists in the system because you can read it or you can see it, right? And so there's lots of things.
But it's not only available. I think importantly, as you're saying, it's not only available in a narrative context. It's like
exactly
you've got individual things that like tools that are documented, and then many narratives that might be documented also. And it's all just a big mess, which like a wonderful mess. And you just walk around and learn.
Yeah, exactly.
Or if someone else presents you with clear paths, then, that's how you start. And that's how any field of knowledge actually is organized.
Yeah, exactly. That's the idea. Right. Um,
Oh, man.
do we have maybe one more question to go through?
Let's see. Um, not a question really, but just a reaction. Like I think what's been happening in my mind as you're showing this to me is I think about when I first encountered test-driven development, or just this idea that you should write. Actually, let's just say at the beginning, okay, I need to learn to write tests. It's really hard at first because you don't write code that's easily testable. But having tests available changes the way you think, and then that happens to a stronger degree with this property-based testing. You start writing code which actually is easier to write properties for. And it seems that we're so good at molding ourselves that we can pull toward good ideas like that, or we can pull toward bad ideas. There's a podcast. I think it was either This American Life or a Radio Lab about this couple. I'm going to get the titles wrong. They were, let's say researchers who decided that they would adopt a young, like a chimp, I guess, into their family. And they also had a son. And so they raised this chimp and the son, and they thought that maybe the chimp would become more human and learn language. But in fact, their son started to adopt like chimp behavior from its peers. So the son is like learning chimp language, and we're so willing and good to change ourselves to good and bad environments. And so the excitement I have when I look at this is that, okay, I'm sure people see this because I show people sort of watered down versions of this and go, okay, I'm not really sure how I'd use that, but. And the fact is, if you start working in this environment, you're going to start making software which is easier to represent and has many ways of performing itself. And like, yeah, the tools in our field make the new world.
Exactly. So let me
yeah,
let me show you this one. So this is actually a case that we have. So this is just an algorithm, right? And it's just a squarified tree map algorithm.
Yep.
And now we wanted to still figure out, this one has multiple steps.
Yep.
And you can just show this one, and you can have a bunch of functions there that do the work, and then just test that the outcome is the one you wanted. But as I said, it has multiple steps.
Yeah.
And what we wanted to debug this was, can we reason about the steps?
Mm-hmm.
And so now you have here this narrative which tells you, okay, this is the first step, this will be the second step. The third step is here, but notice how it fades.
Yeah.
Because the condition is wrong, so then it starts over and does some other things, right? And until it gets to the point, right? It doesn't go to the whole point. But the idea is the following: we didn't have the steps at first.
Yep.
We just had the algorithm.
Yeah.
But because we wanted to depict or create a narrative, then we immediately reified the steps.
Yep.
And now the steps knows how to present themselves, and now we can start reasoning about them. And so there's a very strong, that's like the one of the hidden parts of moldable development is that we started from reading, but we strongly believe that it affects the way we write as well.
Okay, well, I do actually have one more question, and I'm of course sensitive to your time too. But so I'm thinking of some, let's say again, this numerical work I was doing in Clojure, where I did start to think this way. I thought, okay, how could I explain this? And it turns out if you implement these algorithms that are refining an integral estimate as a stream, so a lazy sequence, and as I pull items off, what are the items in the stream? They're the refining steps. And one way to look at it is I have a stream of better and better estimates. But another way to build this is you have a stream of data structures that describe, okay, how many slices, what are the bounds? And so, without any ability to do it, I wrote it the latter way and the former way. Because the way with steps, if I can render each of those, I can just scroll back and forth, and it's so obvious how the thing works. On the other hand, it's a little slower. So the question is, well, one, this environment looks so beautiful. Do you think, or do you have examples of ways to be as seamless with the interop with other languages? Like,
Oh, sure. Yeah, yeah.
yeah, 'cause the closure stuff I have now, I would love to bake into this, but I'd also love to be able to ship an artifact that someone can, that the machine can interact with, because the machine's not going to look at any of this stuff. The machine just wants the sort of uh, optimized fast thing. And I've got ways that I switch between these, but there certainly is the thing you want to show to humans, and then you, right now the machine is primal and humans are secondary, and we want to flip that, but we still want that to be a thing you can do, of
Sure.
course.
Yeah. So definitely, as I said, like Glamorous Toolkit is supposed to be a client-side technology to work with
Yep.
all sorts of other things. Language runtimes is one thing,
Yep.
but nowadays you also have APIs, for example.
Yeah.
So here is such an example. Let's find one here.
And
This
I'll
one
frame
actually.
let me frame as you pull this up, like an example mental model of that algorithm. The way I think in this closure project is, okay, I have a small set of data structures, and then I have functions that act in those things. So I'm out now of I'm kind of out of the mental model of things live in objects, and I'm sending messages, and then the messages. So there's no single place necessarily to look for, okay, where are all the renderable representations of this thing? Because the thing is just a dictionary. So I assume there's some translation that the system has to
That you can
do.
do. Yeah, you would put these kinds of this translation. You would create objects that would start that would make these kinds of translation possible. So, for example,
Yeah.
here, this is there's a whole demo here with a service from
Yep.
Azure that does cognitive. It does face recognition,
Yeah. Yeah.
and you want to then still we wanted to have and so this kind of object over here, this is CS picture, knows how to not only show a picture but also how to show things on the picture, right?
Yeah.
So
Yeah.
so here, for example, we see, oh, this picture has faces, right? But I also
Yep.
see here there are faces.
Yeah. Yeah.
So I can click on one of those if I want, and I can now dive into that, right?
Nice.
So I was here and I can dive there. And now this one has landmarks, right? And then the landmarks are objects too here, and I
Yep.
can go and reason about them if I want. So the idea is that you're going to build the it doesn't necessarily have the runtime doesn't necessarily have to be the same model that you're going to use to reason about it. You can think of it like observability, for example. Today is a
Hmm.
hype type of thing, which is just a subcase of moldable development. In that, uh, you're going to build your system such that it gives you enough signals that you can then compose an interesting view about your
Yeah. Yeah.
system.
Yeah. That got it. Got it.
So
Yes.
here's maybe an example. So I have here a scene, right? So here it is just a scene of composing things such that I can start reasoning about all sorts of interesting, combinations about the result. This is a documentation about how will I interpret the results once I get it from Azure?
Yes.
Because
Yes.
what you get from Azure is just some mumbo jumbo JSON, right?
Yep.
And then we wanted to see this to see does it match, right? So this is why we built this.
Yep.
Okay, but now let's do another kind of let's do another type um, of an experiment here. So what I would do here is I'm going to share now the whole desktop, and so this is now let's say I will go back to one of these. Let's say go here, and what I want to do is um, I want to profile the rendering speed. So there are at least many ways to profile things. So one way would be to say, okay, let's profile it in terms of calls, right? But that's
Yep.
not so interesting. Here's another way of profiling, and this is something we did. So I just started a profile, and so let's say I'm going to scroll here a little bit,
Yep.
right? And I'm going to stop this. And if I scroll now here, what this one shows me are the frames that took more than 16 seconds.
Mm-hmm.
But if I now click on one of those, I will go now into a telemetry task here.
Mm-hmm.
And
Yeah.
this one now actually doesn't give me, it doesn't decompose, gives me a flame graph, but it doesn't decompose it in terms of the, the default message sense or that happened at the call. These are actual signals that came from the graphical implementation.
Mm-hmm.
So the graphical implementation, we want this to be optimized for this, but at the same time, we want it to give me enough signals so that I can start reasoning about it, right? So if I now click on that one, I can go dive into some of those parts, right? And I can see what's going on in there.
Yep.
So that's basically how we think of this of this term. So this is how you can marry in a pragmatic way both the need for optimizing for the machine, but also for the human.
Yeah, this is really powerful. Yeah, I mean, I've seen projects that try to run themselves in org mode, and even when I write, the problem there is you've got source code that's honestly the tooling's so much better for jumping around, and then you're asked to go absorb an enormous linear narrative to figure out how to break that out into the graph. So no one will do it because it just feels it's hard to do. Writing is really hard, and writing, in an enormous long file is really hard. This is kind of different. This is get your tooling or take something which is bootstrapped up enough that it can do something, and then move into Glamorous Toolkit and start augmenting the system with these explanatory elements and laws. And then actually that will probably start driving the development of the system that lives under it.
Right. And so, but the other thing that I haven't shown here is that we already have support for representing languages. Creating editors for those languages.
You said that was the second thing, the second language you built. Yep.
Right, and we are also adding runtime bindings now. So one kind of bindings are to APIs, and there's an interesting type of abilities that you can transform the Glamorous Toolkit into an API reverse engineering tool as well. But we're also adding bindings to languages, and because we want Glamorous Toolkit to be a platform we think the development experience of the future is going to be system specific at least. Well, in our case, it's going to be even finer grained, but at least system specific. That is, if you're going to take a screenshot of a developer working on this screenshot or on this system here, and then there's some other developer somewhere else working on another system, those two screenshots, if I stay 2 meters away from it, they should still be looking differently, right? Today, they look the same. Maybe the only difference is if one chooses the white theme and the other one chooses the black theme.
That's right.
So, and we want people with Glamorous, we want people to build their own environments, and those should hook to all sorts of any data sources that exist, and then they should very quickly mold it to their context.
Okay, so I've built this. I've been calling it a Mathematica Light. It's sort of a computer algebra system, but it's targeted at the work that it's based on this work of Gerald Sussman's that powers a couple of textbooks he's written. And the goal here was to make this a substrate or a computational basis for executable textbooks, or a sort of executable Wikipedia. So where should I start? If it sounds like what I want is the ability to go into Glamorous Toolkit and have all these things available, and also have all this writing and these things that I've sort of half done inside closure namespaces. What would you recommend I do to? I mean, it sounds like this is a wonderful environment. This is the environment people should use to play with that stuff. So what do I do first? Give me the roadmap.
Yeah. So yeah, it definitely sounds like that. And I just took a look at your presentation, and you have it at the end there. Those examples, right?
My couple of little pasted
snippets, exactly.
Yeah,
those.
Exactly.
Yeah, those would fit perfectly well because you need a couple of things. First of all, you need the editor to write your narratives, right?
Yep.
And you saw that all the tools and the pieces, they already exist.
That's right.
But then you might want to embed those. So maybe you want to flip the notations, and have lots of flexibility in how you're composing even your narrative. So that's right. Those are already exist in terms of the basic mechanics. So there's one problem. There's one practical thing that you want to do which is connect to or either implement it in Faro, that's the same logic, which is maybe not the thing you might want to do, or connect, we create a binding for closure, so that we can execute and debug closure from inside Glamorous Toolkit. And
Yeah.
so that's one way to execute those, and then just use Glamorous Toolkit as the environment, the client side, with which to
Yeah, it's got to be that.
to
It's got to be that.
to compose the narratives. And I do think that it's appropriate like that. So that's basically what I would start from. So, but just now, if we go towards closure, there's already an effort to build a parser for closure. It's not that much of a problem, but it would be nice to see the community building it. So that's a nice thing to start from. The binding to closure is the next thing, which actually means translates the binding to a JVM. And then from there,
closure script was just as appropriate.
For JavaScript, the tooling is in place.
Great. So it might be that that's the easier road to go.
Then it's even easier.
Yeah. Amazing. Okay. Well, you've this is the future is here. It turns out. Hey, this is a really
right
beautiful
across
tour.
the corner.
That's right. Tudor, this has been a really beautiful tour. I appreciate you taking the time to show off the system, and man, thanks for all the work you've done on this.
Well, thank you for your time and for your enthusiasm. And so, as I was saying at the beginning, we build Glamorous Toolkits so that people come and have a conversation. We want to, it's something concrete. We can start that conversation. There's a lot to discover going forward. So thank you for that. So if anybody else is watching, maybe one or two other people will be watching this.
Right.
If anybody else is watching, go to gtoolkit.com. You can join us on the Discord. You can also find us there on our webpage, and let's have that conversation.
All right. Thanks, Tudor. Really appreciate it.
Bye.